We're going to look at soil as a productive layer. And we'll start by kind of looking at the succession of soil. And soil will always start off in a new environment with rock that this says disintegrating rock, but you can talk about physical weathering and chemical weathering, where it takes the rock and breaks it apart physically and also chemically through the process called weathering, which then breaks the rock down into pieces and broken up pieces, which you'll see here, and we give that a name. The broken up pieces of rock is called parent material, which you'll see in a minute. At the same time, you'll usually get some form of organic matter, whether it's dead plants, okay, through the wind will eventually settle down, or you may have the top layers of your rock weathered a little bit more and starts to create a more mineral substance on top. Then your parent material continues to break down until you form what we call topsoil, known as the A horizon, which we'll get to in a minute. And that's where you start seeing the topsoil, and then eventually the last stage, a very mature soil, will actually have layers to it. And we're going to talk about these layers next. Okay, so once you develop these layers, it goes from no layers all the way over here and all the way to a very layered soil. And that's kind of the idea. Okay, where soil eventually through time turns into a series of layers, each one with its own characteristics. And we're going to take a look at those characteristics here in a minute. All right, and here they are. Now let's start off with the top layer called the O horizon. All right, and by the way, the layers are called horizons, and the O horizon is known as the organic layer. And that is mostly your humus layer, not humus. All right, it's the humus layer. How much you eat? Humus layer is the layer of dead and decaying material, formed from another word which you love so much, detritus. Detritus is your dead and decaying material, which then, once it breaks down, forms this humus soil. Okay, your next layer is called the A horizon. The A horizon is also known as topsoil. So you have your topsoil layer, and that is the combination that you see in the beginning where I talked to you about the average soil, where it was 25% water, 25% air, 45% minerals, and about 5% organic matter. That is actually the topsoil. That is the stuff we grow our plants in. That's the stuff that we use for farms. It is the most important part of the soil. And then below that, you end up with what we call the B horizon. Now, the B horizon is known as subsoil. Now, subsoil is very clayey, okay, because the clay, being very, very small, eventually gets pushed down by the water and sort of settles down into lower layers of the soil. So your subsoil is very clayey and very difficult to work with. It's hard for plants to grow in there. And the soil just isn't really good. It needs to develop more, needs more organic material. It's lacking all those kind of things. What it isn't lacking are the minerals and stuff that have leached down from the upper layers. If you ever hear the term leaching, all right, that's a term used to tell you that through dissolving of minerals in water, okay, that the substances and minerals in the top layer of the soil work their way down into the deeper layers of soil. Okay, in some cases you're going to find out that's good to get rid of some of the things, but a lot of times that's bad when you leach out all your nutrients out of your topsoil. All right, so you have the B horizon. You usually find roots get down in there, tree roots. It's solid ground that hold the trees up. And then the last layer is the C. And we call that the parent material, which I talked about before. And what the parent material is the bedrock. Let's try that again. Parent material. Let's get rid of that. Parent material is the stuff at the bottom, right above the bedrock, which is the broken up bedrock, which is just, over time will eventually turn into some sort of soil. So these are the horizons. This is what you look for when you study soil. All right. And again, moving right along, let's take a look at more details of soil. Here's two pictures of soil where you can actually distinguish some of the layers. Now, they both have different characteristics. This soil over here on the left is a very clay soil, and you can tell by the red color, all right, down in here. But here you can see almost a line right here, a second line almost right there, and then of course the very clayey subsoil down there. All right. So in this particular case, you're looking at a very, very shallow A horizon with your organic material at the top, and then down here is your B horizon or subsoil. And up here, you've got a very interesting case on the right-hand side over here. We'll call this B, where you have a layer of organic material right at the very, very top. Okay. But you have almost no topsoil when most of this down here is actually the B horizon. So it's almost impossible to distinguish right in this layer where the A horizon is. So what you have is a very, very thin layer at the top, and that's very characteristic of tropical rainforest soils, as you're going to see. Moving along again. Another beautiful picture. I just thought I would try to draw you an extra picture to give you some perspective to go back. And here you can see, by the way, this is an actual picture of that idea of leaching, where you take the material from the upper layers and you see it slowly leaching down into the B horizon, which is that red clay soil. As I said before, some of these soils from different places are very different. All right, in this particular case, if you look at some of the biomes that exist, your forest biomes usually have a very, very good A layer of soil. All right, and then your B layer, B horizon, is about equal, and then the parent material below. But if you go to prairie, you'll see that the A horizon is much, much deeper. Over time, it has been able to develop into a deeper soil. That A horizon being so deep makes it perfect for farmland. Therefore, the prairies in the Midwest of the United States have been converted into farmland, and that's why. Looking at a desert, you will see that the A horizon almost is non-existent. There's a very small B horizon, and then it's all parent material below that. That's typical of the desert. And then in a tropical rainforest, which I just kind of explained, you have a very small A horizon at the top, but then a huge B horizon. A very, very poor soil. It is a myth that rainforest soils are very fertile. That's what you seem to think because you have lots and lots of plants. But in reality, the soils in the tropical rainforest are very poor, and they have very, very large B horizons, which is not a good soil for plants to grow. But the tropical rainforest plants have adapted to this situation, and which makes it a lot easier for them, and you'll learn about that. But what about locally? How can you get soils to differ locally? And in the case of a hillside, you have different soils forming at different places. I think the next slide will be a little bit better. Yeah, this one will be much better. In this particular case, we have two different possibilities. All right, over on the left, we have poorly drained soils, and on the right, we have well-drained soils, which isn't the key in this case. I mean, I'm not worried about that. What I am worried about is the difference in the horizons. This is easily seen in this Allerton area. When you go up on the ridge, okay, the ridge would be represented by this soil over here on the right, where you see a very, very thin A horizon, okay, and now they call it the E horizon, which has a slightly different look to it, but that's actually a B horizon. So you have a much thicker B horizon going all the way down to here, and then of course your C or parent material. So what happens is when you go up on the ridge, you have very, very thin soil, very, very poor B horizon soil, and that's what dominates. But when you go down off the ridge into the valley, we call it Indian Valley, all that soil that used to be up here on the mountain has eroded down slope, and has filled in the valley. And this is a natural process, but what that does then is it creates a very, very, very thick A horizon in the valleys. That is why in our area all of our farms are located down in the valleys, because that's where the soil moved to, and the A horizon moved to. And then you'll see a very, very low B horizon, which is also very wet, being in the valley, which then keeps the soil moist. So you have good soils in valleys, poor soils on mountains. So what you'll see is mountains have forests because we haven't been able to use them for farms, and then we develop, farm, create our towns down in the valleys where they have the good soil. That's good because we have the good soil, but at the same time, down in this area is where you have your streams, rivers, and your floods. So we are bringing ourselves right to the point of disaster by bringing all our homes, our cities, and everything down in the valleys, which are designed to flood, which we'll get to in another unit. But right now, it's where the soil is good.